To move a piano, one of these students is pushing it and the other is pulling it. Each student is exerting a force on the piano. A force has both magnitude and direction. It is measured in units of newtons. The student on the left is exerting a force of 25 newtons to the right. The student on the right is exerting a force of 20 newtons also to the right. Together, the students are exerting a net force on the piano. This net force is an unbalanced force on the piano and causes the piano to move to the right. An unbalanced force is always necessary to move an object from rest. An unbalanced force is also necessary to change the motion of an object that is already moving. Balanced forces cause no change in the motion of an object, whether it is moving or at rest.
Contact forces can arise only from the physical contact of two objects. Other forces, called field forces, do not require physical contact between objects. One example of this kind of force is gravity. The Earth exerts a force on the ball, even when they are not in immediate physical contact. Consider the baseball again. Other than the bat, what else does the ball come in contact with? The air. As the ball moves, it comes in contact with molecules in the air and experiences friction. All forms of friction are contact forces. A free body diagram is a simple drawing that indicates all of the external forces that affect a specified object. To draw a free body diagram, we first isolate the object of interest and the force acting on it. Then we represent the forces with vectors, because magnitude and direction are both necessary in order to define forces. The external forces acting on the car are 1. Its weight, 2. The normal force, which is the force that the road exerts on the car, and 3. The force of friction, or the air's resistance to the car's motion. It is important to note that the forces exerted by the car on other objects are not included in its free body diagram because they do not affect the motion of the car.